So in our previous discussion of simple interest, we made an assumption, right? We made the assumption that the balance in the account doesn't change. In other words, it was kind of like at the end of each period when we got an interest payment from the loan, from the bank, we immediately went to the bank, pulled that interest money out, and that kept the principal amount constant. Well, that's kind of weird. It's really usually not how it works with these kinds of accounts. Usually, you leave the interest alone, right? You leave it in the account. So the principal essentially kind of goes up over time, right? This situation where you continue to earn interest not just on the principal amount, but on the interest that you've earned in previous years has a name. It's called compound interest. That's what we're going to be talking about in this lecture. So I've got a situation here, right? An investment scenario. And it's very similar to what we've seen before. I have an initial investment of $1,000, and I have an interest rate, and I have a time period. And I have a little bit of additional information here, compounded annually, right? When you're doing these questions, you're trying to figure out, is it simple interest, is it compound interest? This is the key word that you're looking for, compounded. Right? That's what tells me I'm looking at a compound interest situation where the interest is going to carry over every month. All right, so let's see how that works. All right, I know that at month, let's call it M0. This is the initial investment, right? In the beginning of the investment, I put $1,000 in the account. So what I want to know is, what's the value of the account at the end of the first month, right? Total value. Well, I've got the initial $1,000 that I put in, plus an additional 2%, 0.02 times 1,000, right? And now remember, I'm not going to get my calculator out and turn this into a number, because remember what I'm trying to do here. I'm looking for a pattern. I would really like to ultimately come up with a formula that lets me do this for any scenario without having to go through all of the individual months one at a time. So what I'm going to do here is I'm going to factor out $1,000. I'm left with 1 plus 0.02. And that is how much money is sitting in my account at the end of the first month, or if you will, the beginning of the second month. All right, so that is my new principal amount. So to calculate how much my account is worth at the end of month 2, I'm going to take my new principal, it's 1,000 times 1 plus 0.02, and I'm going to get another 2% interest of that amount, of that new balance. All right, now look at what's going on here. I have this and this. There's two things that both terms have in common. I'm going to factor that out. If I take that out, I have 1,000 times 1 plus 0.02 times this first term here has a 1 left, and this second term here has 0.02. And now look at what I've got. I've got two 1.02s here. So my balance at the end of month 2 is 1,000 times 1 plus 0.02 squared. Now I'm starting to see a pattern, right? Jump back up here. Let me add something now that I see how this is developing. Go back up here to the month 1 amount. I'm going to put a 1 here. Right? I'm going to write that exponent in because hopefully you're seeing where this pattern is going to start to come in, right? The exponent is, I'm thinking, going to be the time frame. So let's try this one more time. Right? This is actually the final one. At the end of month 3, I would have my new balance, 1,000 times 1 plus 0.202 squared, plus 2% of that new balance. All right, and now look at what's going on. I have this and this. I can factor that out. Factor out 1,000 times 1 plus 0.02 squared. And what's left is 1 plus 0.02, which is 1,000 times 1 plus 0.02 cubed. And now I really am seeing a pattern, right? I have the principal. I'm getting a color here, sorry. there we go. I have the principal times 1 plus the interest rate raised to the time frame, right? And that is where my compound interest formula is going to come from. Now, I do need to make a, you'll see this in the formula in a second on the next slide. I do need to make a small adjustment, right? The interest rates, as we've discussed before, the interest rates are almost always going to be given to you as an annual amount. There's a disconnect here with the way interest is usually paid. Interest is most often paid on a monthly basis. So I need a way to adjust that, right? I need a way to account for that difference. Okay, and here's how we do it. Right, this is my compound interest formula. Right, so let's anytime we have a new formula, especially one that's got a bunch of variables like this, I like to start by just going over all the pieces. Right, so we all know what we're looking at. So A is, think of this as the amount. Technically, it's what's called the future value. That's how much the account is worth at the end of the investment. P is the principal amount. That's how much you put in the account, right? It's your initial investment. R is the interest rate. T is the time. That's the length of the investment, how long you're going to let this money sit. And N, this one is a little trickier to describe. N is the number of compounding periods. I know that sounds a little funny, but look, it's not as weird as it sounds. It's the number of times interest is added to the account per year, right? That's all that really is to it. So let's do a little table here just to kind of get an idea. Let's say time and N. If the interest is compounded annually, right? That's yearly, right? How many years are there in a year? Well, there's one. So if the interest is being compounded annually, N will be 1. If it's being compounded quarterly, well, how many quarters are there in a year, right? There's 4 quarters per year, so N would be 4. Monthly would be 12. Daily, I know there's leap years, and those are a real pain in the neck. For our purposes, for purposes of practice problems and that kind of thing, daily will mean 365, right? We're going to kind of politely ignore leap years. Now, one last comment about that daily figure. There's this thing, it's called the banker's rule, right? Back in the day, when these calculations were done by hand, it made things significantly more convenient if you rounded 365 to 360. And the error that introduces is really, really small. So generally, it was considered okay in the banking world to do that. It's really not necessary today. A lot of these calculations, we have computers and financial and scientific calculators. Doing 365 days is no longer the issue that it was. But you will sometimes see this. I tell you, I have even, for some reason, seen textbooks that do this and treat it as a practical thing, as something you might actually want to do. I have never, in my 30 adult years, seen a bank actually try to use 360 instead of 365 days. In my experience, it's an anachronism. I mention it here just in case you happen to see it in textbooks or examples online or somewhere, because there are people out there who still feel the need to bring this up. Okay, so this is our formula. Right now we kind of see what compound interest is. We have our formula for working with it. So in the next lecture in this series, we're going to go over some examples and see how it's actually used.